Hi, I'm Miss Susan from the Euless Public Library, and this is my assistant.
Brandon.
And this is
STEMtastic Station Virtual Edition.
all right. So today we are going to make DIY lava lamps. So it's pretty easy, and most of the stuff that we're going to be using today you can find in your house. I've already made mine except for putting in this stuff to make it react. So we're going to go ahead and just make Brandon's. So what we're going to do is we're going to do funnel.
Right there?
Yep, we're going to do oil first.
Oil first?
Yep.
I know.
You're going to fill it about 2/3 of the way up with oil. Think you can do that without spilling? I think you can. There you go, right there. I'll tell you when to stop. Okay, that's good. Oop. I think you're good. All right. And then we're going to fill the rest of the way with... And then we're going to do the water. We grab the water. So you need oil and water. So you're going to fill the rest. So 2/3 oil and 1/3 water. Do you think you can do that? Fill
Whole thing?
No, that's too much. Do the whole thing. Fill it almost to the top. Up, up, up. Up, up, up. How about we go faster? Ready?
You do it.
It's probably good.
Yeah, that's probably good.
Alright, and then I put pink food coloring in mine, so mine's going to be pink, and Brandon picked out blue, so go ahead and put about 3 or 4 drops of food coloring in there.
I choose 4 drops.
4 drops, okay.
1, 2, 3, 4, 2.
Alright,
was 2
that should
drops
work.
on the last one.
Okay. You want to let it settle a little bit? Mine's all settled already. So what it's doing is it's separating out the oil and the water. Alright. So do you have your, so we have oil and water, and then your food coloring, and then we're using Alka-Seltzer tablets.
Which goes inside of here.
Mhm.
Then it goes inside of these bags.
Mm-hmm.
And then they add up like this.
Yep. You could also use like baking soda and vinegar. You can also use salt. That also works as well to create almost the same effect. All right, you want to do it? You want to break yours into pieces so it's easier? Oh, all right. Do the one, yeah. Do that one first. Yeah, drop it in there.
Whoa.
No, watch.
Whoa.
There you go.
Bubbling! Mine's not finished with the bottom color.
Here, I'm gonna put the lid on it and we'll shake it up a little bit, and then I'll get the blue in there. You can see the blue.
Oh, I can see the blue.
Mm-hmm. Put the blue in.
It might get a little bit wetty.
There it goes. Can put more in there.
A little bit more. Or I could put half of it. Dunk. Well, I wonder what will happen.
Cool.
Whoa, it's going so fast! It goes so fast. How do the bubbles go up and don't pop?
So what you can do, if you wanted to, if it runs out of the Alka-Seltzer, you can always add more.
I guess I could keep one.
You didn't keep one? Just make sure you realize that it is releasing a gas. So if you screw the lid on it, you might want to, yeah. Or you can, I mean, it'll react more with it on, but once you'll have to let the gas out. Otherwise, you might make a mess. All right, that's all I got. Stay tuned for the science. Bye.
Bye.
So let's talk about the science of the DIY lava lamp. The first thing we should talk about is density. Density is mass divided by volume. That means if you have two substances of the same volume, the one with more mass will have more density. Density is the measurement of how compact a substance is. Since water is heavier than the same amount of oil, or water molecules are packed more tightly than oil molecules, water is more dense than oil. When you put both water and oil in the same container, the water sinks to the bottom because it is more dense. The second thing we should talk about is polarity. Water is polar, meaning that one side of a water molecule has a positive charge and the other side has a negative charge, which attracts other molecules of the opposite charge. Oil is nonpolar. It does not have a positive nor negative charge and therefore is not attracted to water at all. Because of this, water and oil don't mix. So the lava lamps we have made are not quite the same as real lava lamps. Real lava lamps are powered by heat, and the substances used are not the same, though the same science principles are used. Our lava lamp is powered by a chemical reaction. When you add the Alka-Seltzer, it reacts to the water and creates carbon dioxide. These carbon dioxide molecules attach to water droplets, and because together they are both less dense than oil, they rise to the top. Once the gas bubble reaches the top, it pops and releases the carbon dioxide, allowing the water to sink back to the bottom. This all creates a very similar effect to what you see in a lava lamp.